This is question number 4. We are told that an unstable atomic particle decays in mass by half every 2 hours. We're then told that at the end of each 2-hour period, it is bombarded by atomic matter, which allows it to recover a mass of 12 AMU. Part A says, by considering a suitable recurrence relationship and taking the original mass of the particle to be 40 atomic mass units, calculate the number of hours it will take to decay to a value which is below 32% of the original mass. So what we need to do first is find out what 32% of the original mass is. So that's 32% of 40. If we do that calculation, then we get an answer of 12.8. So what we want to do is we want to calculate how many hours it will take to decay below this value of 12.8. Now, in order to get started, we need a suitable recurrence relationship. So we have UN plus 1 equals, and we need a multiplier. So we're told that it decays, which means it's decreasing, and it's decaying by half. So because it's decreasing, it must be 0 point something, and because you know it's decreasing, decaying by half, then it must be 0.5. So it's 0.5 times UN, and then we're told that after it is bombarded, it recovers a mass of 12. So that means we are adding 12 at the end. So what we should do first is go ahead and work out U1, the mass after the first period of time, which is 2 hours. So that's going to be 0.5 multiplied by U0, the initial mass, which we know is 40, add 12, so 0.5 times 40, that's 20, add on 12, that gives us 32. So after the first period of time, the first 2 hours, our mass is now 32. We'll go ahead and work out U2 the same way. So we have U2 equals, and that's 0.5 multiplied by the previous term, which is 32, add on 12, and that gives us 28. Similarly, we can go ahead and do U3. So this time it's 0.5 times 28, add 12, that gives us 26. So we can see our mass is falling, 40, 32, 28, 26, seems to be slowing down. So U4 is 0.5 times 26, add 12, that gives us 25. So it's continuing to slow down each time. That suggests that we're approaching a limit. So U5, our next term, is going to be equal to 0.5 times the previous term, which was 25, add 12, and if we do that, 0.5 times 25 is 12.5, add on the 12, that gives us 24.5. So it does seem to be approaching a limit, and that limit seems nowhere near the figure we're looking for, which is 12.8. We could continue on U6, U7, U8, U9, and so on, But if we were to continue to do that, we would find that we are going to get closer and closer and closer to 24. And that leaves us with a problem because we're looking for a point where it falls below 12.8. So the answer isn't that it doesn't fall below 12.8. What we have to do is think carefully about the situation. Now, our initial mass was 40 atomic mass units. U1, the first period of time, which was 2 hours. After that 2-hour period, it had fallen from 40 to 32. Now, that doesn't mean that the lowest mass in that 2-hour period was 32, because if you remember back to the question, we were told that at the end of each 2-hour period, it is bombarded by atomic matter, which allows it to recover 12 AMUs. So this plus 12 is added at the end of the 2-hour period. So if you imagine that just before this plus 12 had been added, we would have actually fallen to a much lower value. We had 0.5 times 40. So 0.5 times 40, the initial value, that is actually as low as 20. So that meant that during that first 2-hour period, the mass fell as low as 20, but at the end of the 2-hour period, 12 was added, which brings us back up to 32. So what we need to consider is not the final value at the end of each period, but the value just before 12 was added on. So with this one, 32 was the final value. Just before the 12 was added on, that meant 32 minus 12. That one would have fallen as low as 20, still too high. U2 was 28 after the 12 was added. If we subtract 12 from that, then we get 16, which is still too high. Considering the next one, at the end of this 2-hour period, our final value is 26, but just before the 12 was added, that must have been 14, still too high. At the end of this 2-hour period, our value was 25, but just before the 12 was added, that means it was as low as 13. So we're getting close to this value, 12.8. At the end of the 5th period, it was 24.5. Just before the 12 was added, it must have fallen to 12.5. Now, that means that during this 2-hour period, the mass had fallen to 12.5, but at the end of the period, 12 had been added, which brings it back up to 24.5. But during this period of time, the mass had fallen as low as 12.5. The question was, when does it fall below 12.8? And it's during this 2-hour period, U5. Now, the question was, how many hours will it take to decay to this value? Now, if each recurrence relationship, each one represents a 2-hour period, then U1 will be 2 hours, U2 will be another 2 hours, which is 4 hours, 6 hours, 8 hours, 10 hours. So the answer is it takes 10 hours to fall to a value which is below 32% of the original mass.